really just carbon and hydrogen. And what you have are carbon atoms that you represent with a C right here, and you have hydrogen atoms. And the way that they are arranged is what makes rubber so special. Synthetic rubber is made up of two different kinds of molecules put together. And one of them is butadiene. And that looks like this. Like this. And each one of these H's represents a hydrogen atom. And each one of these C's represents a carbon atom. And each one of these little sticks right here actually represents a bond, which is a pair of electrons that is shared between these two atoms. And if you have two sticks, then that would represent a double bond, which would be two pairs of electrons, so 4 electrons total, that would be shared between these atoms. And the sharing of electrons holds the atoms together, kind of like glue. So this is butadiene. And then you have styrene, and styrene is kind of funny. Well, let me show you the unit here. Styrene is going to be, I forget exactly, but it's something like this. Then attached to that, you have a whole ring of carbon atoms. Like that, and then each one of those attached to hydrogen. I may have the exact formula not exactly correct, but it's something pretty close to this. And so what happens is, long before the rubber ever makes it onto your pencil, the butadiene, which is going to be some kind of a gas, and the styrene, which is going to be some kind of liquid, are actually reacted together to form styrene butadiene. And then the whole thing is, if you can imagine these two sort of coming together like tinker toys. Okay? And then the whole thing is treated with a polymerizing agent that causes them to link together and form really long chains. And when you do, you get something that looks like this. Boom. And this is just one little piece of the chain. So if you can imagine going off the chalkboard, off the board here, and all the way down past the end of the building in either direction. Just really, really long chains of this. That is polystyrene butadiene. That's your synthetic rubber. So the synthetic rubber is made up of these really long chains here, and it's pretty much liquid in this form, or it might be a low melting solid. It's not hard enough to be an eraser. So now something else happens, and that is a process called vulcanization. And the vulcanization takes one really long chain, just like you see here. I'm going to represent that with a squiggly mark, like so. So here's our long chain. And it takes another long chain, and it heats up those chains with some sulfur. And as a result, sulfur atoms start to link across like that. Usually it's 2 sulfur atoms, but sometimes it can be more. Will link across from one carbon atom in one chain down to another carbon atom in another chain. And the result is those chains now get locked together. And when they do, the whole thing gets stronger. And as a result of being stronger, depending upon how much vulcanizing you do, your rubber can be softer or harder. So for car tires, for example, there's going to be a lot of vulcanizing that goes on so that you get really strong rubber that can go on the roads. For pencil erasers, you're going to have a lot less vulcanization. This vulcanization is really the big obstacle for recycling the rubber. If you could take your rubber and get it back to these really long chains in the liquid form, then you would be able to reuse it and turn it into something else. So what you have to do is to break these sulfur bridges between the various chains in order to recycle it. And I believe that that is the purpose of the solution that we found. Monochlorine. Does that help?
Yep. Do you know what SBR polymer is?
This is exactly what we were just talking about. SBR, styrene butadiene, and the polymer means it's made up of many units.
exactly what I was looking for.
Okay,